Hi everyone, this is part one of me going through section B questions for the GCSE exam. So I've picked out all of the second section questions from all the previous papers. We're going to go through each one, so hopefully give you a better idea of what might come up in the real exam. Okay, so just a quick reminder that section B is asking you all about basically what you know about your specific material area that you're focusing on. So our specific material area that we should be focusing on is polymers, but into that you are able to bring in your knowledge of woods and metals as well. So for big questions that you need to give lots of detail, you're probably going to want to stick with polymers, but as we go on later I'll show you that if you're not sure about a particular polymer question, you can answer it with some of your knowledge of like timbers and metals. Okay, so first question here. Study the high chair in figure 2. This one is all about forces. So it says identify the force acting upon each of the following 3 parts of the high chair when in use. So we've got the legs here, the seat and the straps. So the types of forces that we can be talking about are bending, we've got tension, we've got compression, you've also got torsion, which is like twisting, and you've got shear, which is when something moves kind of like in opposite directions on a flat plane, almost like tectonic plates in geography. So we're trying to think of which one of these you might put for each of these. So the legs, if there was, imagine there's someone actually sat in this high chair, child in this high chair, those legs are probably going to be under compression. You could also, for this one, get away with saying a bending force, because potentially it could be bending along the leg. The seat, I would definitely say it's compression, and in the mark scheme, if you put compression for the first 2, you would still get the marks. And the straps, when they're actually pulled tight, they are going to be pulled apart or pulled on either end, so that one is tension. So that would be your 3 marks there for that question. Right, question 16. Now, this is a classic question that can come up in the exam. And this one is one of more of the tricky ones, because this gives you, 1, 2, 3, 4, 5 different options. But from a polymer point of view, there's not an obvious choice. So the one that I'm going to go through is called lamination, how you can bend plywood using layers of plywood. And some of you will have done that for your NEAs. So that's the one that I'm going to pick. Printing would be for sort of like paper and board. Sewing is obviously for textiles. Soldering would be for electronics. And welding would be for metals. But you can actually weld polymers together. It's basically just heating them up and sticking them together, so you melt the 2 plastics together. But the one I'm going to go for is lamination. Now you're probably thinking, well, like what, like laminating paper in like a little plastic pouch? Well, actually that would get you marks in this question, but the steps I'm going to go through is how to do plywood lamination. So these are the steps that I would put for this question. So it says the first step of lamination is to create a former. So what we mean by a former is like a mold. So say we were making a shape like this, we would need a maybe a piece of styrofoam or something that was actually this shape. So I'm trying to draw that in 3D for you. So imagine that's a piece of styrofoam and that's been created to the shape that we want our plywood to take. And like I said, it could be styrofoam or it could be MDF. So it's made from quite inexpensive materials. So that's kind of step 1. Step 2, veneer strips. So thin bits of plywood are then cut. So the way that I would show that is just to have some different pieces. Obviously the number of pieces that you have would determine how thick the plywood's going to end up, but also how like rigid it's going to be, how stiff it's going to be. So that's what I've put here. The thickness is going to change the strength of the final product. Then what you're going to do is you are going to layer them together. So I'm going to do kind of like a side view, and then you might have PVA in between the layers, and those are all like squashed together. The plywood is then bent around the former and secured with clamps or a vacuum bag. So some of you may have done this process where you bend the plywood around the former. So say that's the former, this is the plywood here, taking the shape. And then you might, for example, put some clamps that are going to apply pressure across it. But the other thing that you can do is put it in a vacuum bag. Like some of you will have seen, I did it with quite a few projects this year. And what that does, say that's your thing in there, drawn it really badly, is all the air is sucked out and it applies pressure across the entire area of the product. Then all I've said is to leave it for 24 hours. It's removed and the edges are trimmed and finished. So you end up with something that looks maybe a little bit like this. So plywood layers on the side and all the edges and things trimmed off. So watch out for this. Lamination, you can talk about laminating paper and card, but you'd probably struggle to get the full 6 marks. So lamination of woods and plywood is a good way to go if that does come up. Right, the next one. Name one process used to remove waste material to make different parts of a prototype. Describe the process you have chosen. This I gave to one of my year 11 groups once, and they really did not know how to answer it. They didn't understand what remove waste material meant. They thought it meant like to take the bin bags out or like to recycle something. Basically, when you remove waste material, you might be cutting something, you might be drilling, you might be using a hand router. But basically, a wastage process is removing material. So if you're making your prototype out of wood, you might use one of these processes here. You might do some drilling, you might saw it, or you might sand it. So it's as simple as this. It sounds a lot more complicated than it is, so it's quite simple. So if we were talking about drilling, this is all you'd need, a description of the chosen process. Drilling, if a hole is needed in a material, a pillar drill can be used to remove this. So there you go, you get a mark already for that. A specific sized drill bit would be selected and put into the chuck of the drill. If you forget some of the key terminology, don't worry, just have a go. The material being drilled would be clamped down to ensure it didn't move during the drilling process. So that would be your 3 marks there. If you wanted to talk about sawing, if a material needs to be cut into sections, you could use a saw. For timbers, a tenon saw would be suitable. That's the one that looks like this. You would have seen it in the workshop. It's normally got like a bit along the back of it because it's really good for cutting straight lines. The material would be clamped or held against a bench hook. If you don't remember what a bench hook looks like, it looks a bit like this. I'm drawing this really badly. That bit goes into a vise and basically you put the wood up against it and then saw against it. That's a terrible drawing, I do apologise. A tenon saw cuts very well in a straight line. If a curved cut is needed, a coping saw or fret saw could be used. So coping saw is the one that looks like this. So it's got a thinner blade and the frame looks like a C, so you can cut curves. And the fret saws are those powered ones around the side of the workshop, the ones that always scare people because they bounce up and down quite often, and they're powered, so they are going to be able to cut nice thin lines as well. So that again would be your 3 marks. Next question, or sorry, next example, sanding. We've all done this in your NEA. If the surface of a material needs to be sanded to remove rough edges, a disc sander could be used. The material is pushed up against a rotating disc that abrades or sands the material away. This is most suitable for timbers and plastics. The material must be held flat. For safety and eye protection must be worn. So I think that's a really easy 3 marks, but the reason that you might struggle with it is because AQA are evil and the questions that they ask are confusing. So removing waste material means like cutting something or taking away a bit that you don't need from a material. Right, next question. Explain the purpose of quality control. So this is the answer that I came up with. Quality control is used to ensure products are manufactured to a high standard and meet the expectations of the customer. Now, quality control is done after each stage of the manufacturing process. And you might be checking things such as dimensions or surface finish, or that something is in tolerance. So when we say if something is in tolerance, we say it might be plus or minus a certain measurement. So if a component was plus or minus 1 millimeter, if we checked it, if it was outside of that, so say this was 5 millimeters long and it had a tolerance of plus or minus 1 millimeter, which is quite a lot actually. If it was 4 millimeters, it would be fine. If it was 6 millimeters, it would be fine. But if it was 2 millimeters smaller or 2 millimeters bigger, then it would be out of tolerance. So quality control, tolerances are used quite a lot. Next question, describe one method of quality control that is used when making prototype products. This is quite tricky because you need to know something specific. And this is where this thing comes in. It's called a go, no-go gauge. And this can be used to check the size of holes quickly and simply. It looks a bit like this. On one side, it has a green end. And on the other side, it has a red end. Okay. And these are made to specific measurements. And what you do is say you were checking the hole on a piece of material, so say there was a couple of holes on here and you needed to check them. This is the go side, so that basically needs to fit in the holes. So you use one end and if it fits in, that's great. It's within tolerance. But if the red side fits in, then it's not in tolerance because that side is a no-go. So it should fit in on one side but not fit in on the other side. That's a bit confusing. But this is called a go, no-go gauge, and it's a really quick way in industry that manufacturers can check dimensions of things quickly without having to get measuring tapes out, and also human error can be an issue on that as well. So a go, no-go gauge can be used to check the size of holes quickly and simply. One side of the gauge should fit, so the go, and the other shouldn't, the no-go. This means that the product is within tolerance. The method eliminates human error and speeds up quality control checks. So if that is all a little bit confusing, maybe have a look at that. There are other quality control checks that you can put in. So I'm just going to rub out my beautiful sketches here, because the other thing that you can talk about with this is you can talk about a depth stop. So say you were drilling into a piece of material with a drill bit, you can actually have something that's mounted onto the drill so that when the drill gets to a certain point, it's actually going to stop it from going in any deeper. So the drill will only drill to a certain depth. So these are used a lot to make sure that things are drilled to the correct distance, especially in things like flat pack furniture and things like that. So a depth stop can be used to ensure holes are not drilled too deep. This is attached to a pillar drill and it physically stops the drill from going past a certain depth. That would get you the 2 marks as well. Right then, this one is one that could really catch you out. Okay, so this one here, it says choose one of the material categories in the table below. Don't make the mistake that lots of my previous students have made and gone, oh, I'm not sure which one to pick. Oh, I'll go for textiles. Okay, it's obvious. Well, to me, it's obvious. I would forgive you if you went for metals or woods. I would forgive you. But the problem is that look later on in the question, it's asking you to use notes or sketches to describe the process that you've named above. You haven't learnt how woods are transformed into stock forms. You haven't learnt how metals are refined from their ores. You might have done in science, fair enough, but you haven't learnt how papers and boards are made, and you definitely haven't learnt how textile materials are made. So hilariously, what I've had in the past is I've had chosen material, textile, then I've had sheep, then I've had shaving, and then I've had someone draw a poor little fluffy sheep getting like shaved by a farmer. Okay, please don't do this. Please, 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 please don't do this. Okay, you need to look carefully at the question, because if it's asking you to describe a process, or there's loads of marks for you doing a diagram or something, think, what have we learned in lesson? And what we've done, not so recently, and you've done this in science as well, is we've learned about fractional distillation. Okay, that is the process here that you need to be talking about. So it says here, give the source or origin of your chosen material category. Well, polymers come from crude oil. Okay. Then it says, name one process used to convert your chosen material category into a workable form. Now, this is where you can go wrong. You can go really wrong here. The mistake that you can make is you could put something like injection molding, or you could put extrusion or blow molding. Okay, this is wrong. Wrong, 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 wrong. Because this is asking you, how do you actually get it into the form before you actually do any commercial processes. So the process is called fractional distillation. Okay, and please forgive me, I'm no chemistry teacher. This will be a simplified version of how this works, and that's all that's required. We don't need to know the condensing points or the temperatures. We don't need to know all the names of the different chemicals. We just need to know the basic steps. So it says, using notes or sketches, describe the process you've named above. So the first thing that I would talk about is crude oil is heated in a column. I think it's called like a fractional distillation column or something like that. Okay, there'll be different ways of talking about it. Please follow whatever your chemistry teacher has taught you. If they've taught you this, I'm going through a basic step, okay, a basic steps of it. The crude oil is heated, so I would draw something like a flame. Oh, that looks awful, but you know what I mean. I'm going to rub that out. So draw something like a flame or something underneath, which shows that it's being heated. Okay. The crude oil evaporates and it basically condenses at different temperatures. Okay, so it splits it into different fractions, and these are collected. Now, just so you know, the chemical that is used for polymers is called naphtha. Okay. So that could be something that you pick out if you really want to, but you could still get full marks on this without mentioning naphtha, okay? So we've split them into different fractions. They can be separated to be used for different purposes. These are important here, okay? After that, once you've done it, you need to do polymerization to create some long chain hydrocarbons. And then to make them more useful, you then do cracking, which turns them into more useful chemicals, shorter chains, and that's where naphtha comes from, which can then be used to create things like ethylene and the chemicals used for polymers. Okay, so I'm sorry if I've made any mistakes there, but I can tell you now that that would get you full marks in the product design exam. It might not get you full marks in the chemistry exam, but it's the general understanding of the process that will get you the marks. Right, big beastie question here. There is usually a big 8 marker in section B. So this one says, the design and manufacture of products has an effect on our planet and environment. So you should be smiling at this point because this is about sustainability. So you can bring in lots of general knowledge, lots of knowledge from geography, lots of knowledge from science into this. Okay, so it says, analyze and evaluate the issues a consumer may consider before deciding to purchase products. Give examples in your answer. So that's important. If you don't give examples, you're probably going to restrict the amount of marks. Well, you will. You'll restrict the amount of marks that are available for this question. So I'm going to show you the answer that I put together and talk it through, but this is just one type of answer. The nice thing about the product design exam is at the end of every bit on the mark scheme it says, accept any other valid responses. So here we go. This is what I've kind of tried to split it down into thinking about the life cycle of products, so almost like a life cycle assessment, thinking about the carbon footprint, and a little bit of thinking about the 6 R's. Okay. So here we go. A consumer may consider how the raw materials of a product have been sourced. So there you go, mark there already. A lot of damage can be done to ecosystems when materials are extracted. Deforestation is a huge issue with damage being caused to rainforests and animal habitats. Lovely. Well, not lovely, bad. Drilling for oil can cause oil spills and destruction of the seabed, which can pollute the surrounding environment. So already 4 or 5 marks in that first paragraph. The carbon footprint of a product could also be considered. If a product has been manufactured a large distance away from where it's being sold, a high amount of CO2 will be created due to the use of fuel. Customers may choose to buy products that have been manufactured or locally sourced, such as fruit grown in the UK rather than South America. Okay, good example there. So there's our first example that we've kind of put in. Also, deforestation is an example, and so is drilling for oil. So I'm already putting examples. A consumer could also consider the 6 R's when buying products. So whenever you see anything about sustainability, do always think about the 6 R's. It is desirable to buy a product that can be repaired, as this extends its life and reduces the likelihood of it going into landfill. If the product is made from recycled materials, less harm will have been done as raw materials have not been used. For example, clothing made from plastic bottles. Consumers may refuse to buy products that use polymers as they are a finite source. And here's another example. A biodegradable polymer such as PLA, and PLA is the stuff that we use for the 3D printer, if I can actually say it, PLA, comes from plants. So PLA could be more desirable as it is from a renewable source. So I would say that's probably overkill, but that would definitely get you the 8 marks for that question. Right, this is from the 2020 past paper. So this is the section B for this one. This one starts off with a 4-marker saying, name one specific commercial manufacturing process and describe what it is used for. So this is not asking us to explain how we get it from a workable into a workable form. So this is not fractional distillation. This is commercial. So this is how you would actually manufacture a product. So this is where you can talk about things like injection molding. You can talk about blow molding. So I would highly recommend that you know these diagrams. You could talk about extrusion. You could talk about vacuum forming, especially if you've done that in your NEA project. That would be a good one to talk about, but I would recommend going for one of these ones. And these processes, especially the first 3, injection molding, blow molding, and extrusion, all have the same sort of beginning bit to their diagram. So you're going to start with, it says using notes or sketches, describe the process you've named above. They all start with a hopper. Then what happens is you have a barrel and you have an Archimedes screw. So this is almost like, I can't really draw it. It's like a spirally thing. Oh, it's awful drawing. But it basically like helps to transfer things. It was usually used to pull water out of the ground. So it's called an Archimedes screw. I'm not going to have enough space really to make the notes. This is called a hopper. So the granules of plastic are fed through the hopper. They go into the barrel. There is a motor here. And basically at the end of this, there is a mold. So you might draw something like that, for example. So this is called the mold. Make sure you spell it correctly with a U. And the steps are things like granules or powder are fed into the hopper. I'm not going to write the whole thing out, so just listen to me maybe and make notes. Goes into the hopper, it goes into the barrel where the Archimedes screw kind of pushes the granules forward, and there's loads of heat on either side of the barrel which heats the plastic up and turns it into almost like a toothpaste consistency. So basically melts it. And then what happens is the motor injects the plastic, helps to inject the plastic into the mold. The mold, once the plastic has cooled, the mold splits apart and the plastic part is ejected. Okay, so this is injection molding. Blow molding is similar, except at the end you would have a tube that is extruded into a mold like this. That then closes and air is pushed in, so it makes the bottle take the shape of the inside of the mold. And extrusion, the only difference is when it comes out of here, it goes through a die, like a sort of like a shape, say like a star shape, think Play-Doh factory, and then the plastic would come out in that kind of cross section all the way along. So it's sort of like that. So you'd have the same cross section all the way along. That is used for things like pipes, stuff like that. So big recommendation to make sure you know your plastic commercial processes. There is a PowerPoint and a video about them, so learn them. Right, question 15. Explain why each factor below would need to be considered by a manufacturer when sourcing materials or components. So this is 2 lots of 2 marks, so 4 marks in total. Bring in business knowledge. If you know business knowledge, don't be afraid of doing that. Bulk buying. If materials and components are bought in bulk, the manufacturer can benefit from economies of scale. This can mean that the cost of the materials could be significantly lower if bought in high numbers. So that would get you the 2 marks there. Ethical factors of buying materials and components. So you might want to think about like where they're coming from, how the workers are being treated, if you are depleting a finite source. So this is the example I have written. Ethical factors such as the safe extraction of materials and working conditions must be considered when buying materials or components. The extraction of some materials, for example precious metals, can cause major issues including conflict and destruction of habitats. So the example I'm thinking about here is the Congo, the Democratic Republic of Congo, where things like a material called tantalum, which is used on your mobile phone, is mined, and there is a huge amount of conflict caused by having the sort of ownership of those mines. Loads of conflict, and also things like landslipping, mudslides, destruction of rainforest, all sorts of stuff happen. So ethical factors, you could bring in lots of different examples to that. Right. Next question. This is a funny old question, this one. It's only a 3 marker. Okay, so this is the kind of question where if you wanted to bring in other knowledge of other materials, you could here, because it's not asking you to like describe the manufacturing process or write a huge long thing. It's just asking you to name a material that would have been used for the products in the pictures that you can see, a stock form. So what the heck is a stock form? You might be thinking, well, a stock form is how you would buy the material. So for example, for wood, you would buy it in planks. For plastics, you might buy granules or powder or sheet, like acrylic sheet that we use on the laser cutter. For metal, you might buy it in a metal bar, metal tube. Yeah, so pretty much that's what a stock form is. And how would you finish that? So a finishing technique. So this is where I actually think this polymer one is quite tricky. So it's asking you, say we did the polymer gears, it's asking you a specific main material. So this is where you need to bring your thermoplastic knowledge in. So for a product like this, it might need to be a bit flexible and fatigue resistant. So polypropylene. Oh, I've just remembered actually, I've got this just written on there. So hang on a second. Polypropylene would be a good one to write down. It's a thermoplastic, could be injection molded. You'd get the bright colors, the pigments, but it's also resistant to like flexing and things like that. Or you could do HIPS, high impact polystyrene, and is got a resistance to sort of impact, so suitable for a toy like this. How would it come in its stock form? It would be in granules or a powder. So I've given 2 answers for each, so just 1 answer for each is all that's needed. So this would get you the marks. And this is where you might get stuck, because you might go, well, what kind of finish can you put on plastic? Well, hopefully you'll go, oh, plastics don't need a finish, they are self-finishing. So what you could write is self-finishing, so not required, that would get you the mark. But also you could say that pigment is added during injection molding. So the colour is added during the manufacturing process. Now, if you wanted to answer about any of the other materials, this one's a nice one to do, the wooden toy, because you could name pine, beech, you could even name plywood, they would let you have that. Stock form, plank or sheet, you would get the mark. And then a finish, paint or varnish or wax. So that's relatively easy. So with questions like this, where it's only a short answer question, just go for the one that you think you know. Don't worry that it might end up you might not quite know how it's made, because you're not being asked that, you're just being asked a short amount. So check the question before you pick what you're going to talk about. Right, maths. This is not too hard a maths question, actually. Even I could do this one. And you might recognise this one from your mock, but if you've forgotten it, I'm going to go through it really, really quick. A number of calendars are being made, given the sizes provided in figure 5 and figure 6. How many calendar pages can be made from one sheet? So the first thing we need to know is how big is this sheet in the first place. So always write down all you're working out, okay? So the first thing that you would do is work out what the area of this is, millimetres squared. So you're going to do 1187 times 841. That gives you 998267, okay? Then what you need to do is work out the area of a calendar page. So you go 280 times 210, which gives you 58800. The next thing you need to do is divide them. So how many of those fit into there? And what you get is 16.977. Now, you can't have 0.977 of a calendar. So the answer for this is you could make 16 calendar pages. Now, the second part of the question is asking you, what percentage of material is waste after cutting the pages? So show your working, and look, here we go. You would lose marks if you don't pay attention to this. It wants it to 2 decimal places. So the first thing we are going to do is we're going to work out how many, basically how much 16 times this amount is. So 16 times 58800 is 940800. Then what you need to do is take them away from each other. So the total of the entire sheet, this sheet here, 998267 minus 940800, that gives you a leftover amount of 57,467 millimeters squared. That's left over, but it's asking you a percentage. So we need to know as a percentage what that is of the total amount. So you obviously divide it by 9,98267, then you times it by 100. And rounded up to 2 decimal places, that gives you 5.76%. Lots of you will see this as 5 really easy marks. That's a really easy maths question, I think, anyway. If I can do it, it means it's easy. Right, the next one here. So ignore my answer for a second here. This is another big old chunky 8 marker. And it says responsible design should consider social issues in the design of manufacture of products. Analyze and evaluate how pollution caused by the manufacture, use and disposal of products can impact the environment. So it's talking about manufacture, use and disposal, which makes me think of a life cycle assessment where you do the extraction and you do the processing, the transport, the use, and then the disposal. So a life cycle assessment, which I think you do in science, is a really good thing to bear in mind, especially with anything to do with sustainability of products. So, but this one is specifically asking about pollution. So you could talk about water pollution, you could talk about air pollution. So it needs to be carefully linked to the creation of pollution. So here we go, this is what I've written. Pollution can be caused at various stages of a product's life cycle. During manufacture, atmospheric pollution can be caused by the burning of fossil fuels. During commercial processes such as injection moulding and blow moulding, this generates large amounts of CO2, which contributes to global warming. Relatively simple, gets you a few marks already. So here I'm thinking a little bit more about my life cycle. During the extraction of materials such as crude oil, spills could happen that could pollute the surrounding water and destroy habitats and kill wildlife. So I reckon there's already a good few marks in there. The disposal here, I'm talking about single-use plastics. So there's some of my examples again, because this is asking me to give examples. Single-use plastics can cause a lot of pollution during their disposal, as often they are washed into water sources and gather in large pools of rubbish in our oceans. These can be ingested by sea life and will pollute our food sources and water supplies. So that's when plastics can be washed into water and gather into those big garbage patches. Another big problem with polymers is they can degrade into microplastics, which can enter our water sources and be easily ingested by marine animals. This is especially dangerous as they cannot be easily removed due to their small size. So I don't think I've spoken about much there that any of you would not be able to bring into this answer. It's just drawing on your knowledge of the impact that the life cycle of a product can have. Okay. Right, I'm going to stop there and carry on with this question in part 2. So well done, you've made it to the end of this part. Part 2, we'll carry on with these sections and go through the rest of the answers. Right, see you on the next video.